For today, I'll discuss on Quarter 1, Module 3, Mathematics 9, Nature of Roots of Quadratic Equations. So let's have first activity 1 here, which are real and which are not. So direction, put a check on the corresponding box that best describes the given numbers. Answer the questions that follow. So you will just check here if the given is real number or not real numbers. So when you say not real numbers, example of this one is square root of negative 16. Okay, so this is an example of not real numbers. So if we're going to have the square root of negative 16, there's no number in which if you're going to multiply twice itself can result to negative 16. So that is why it's called as not real numbers, or this one is called as imaginary numbers. So your clue here is you can describe not real numbers when you have a square root sign and negative number inside the radical sign. Then activity 2 here, do I know my ABC? So direction, tell whether the given quadratic equations are in standard form or not. If not, rewrite the equation in the form ax squared plus bx plus c equals 0. Then identify the values of a, b, and c. So let's have example number 1 here. I will just answer this one. So 6x squared plus 11x minus 35 equals 0. So this one is in standard form, so you'll just copy 6x squared plus 11x minus 35 equals 0 in the blank. Then the value of a here is 6, b is 11, c is negative 35. Then number 2 is not in standard form, so you need to write this one in standard form and put your answer in the blank. Same with the other numbers. Then activity 3, find the values of b squared minus 4ac. So evaluate the expression b squared minus 4ac given the following values of a, b, and c. So number 1 here is a equals 6, b equals negative 2, and c equals negative 3. So b squared minus 4ac. So this will be equal to, b here is negative 2, so negative 2 squared. Then minus 4 times a is 6 times 6. Then times negative 3c. Negative 2 squared equals 4 minus 4 times 6 is 24 times negative 3. So negative 24 times negative 3 is positive 72. So this is plus 72. 4 plus 72 equals 76. So the value of b squared minus 4ac for number 1 is 76. Then you're going to do the same with numbers 2 to 5. Then what is it? So we have already studied the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a. So the binomial inside the radical sign is called the discriminant. It is used to determine the nature of the roots of a quadratic equation. We can also determine the number of real roots for a quadratic equation with this number. So the following table will give us the relationship between the discriminant and the nature of the roots. So in this one, square root of b squared minus 4ac, b squared minus 4ac is called as the discriminant. Okay, so let's have the table here. Discriminant b squared minus 4ac equals 0. So if the value of b squared minus 4ac is equal to 0, so the nature of the roots, real and equal, and number of real roots is 1. Second one is b squared minus 4ac is greater than 0 and a perfect square. So the nature of these roots will be rational and unequal, and there are two roots. Third one is b squared minus 4ac less than 0 but not a perfect square. So this is irrational and unequal, and there are two real roots. And the fourth one is b squared minus 4ac less than 0. So the nature of the roots is imaginary or no real roots. So number of real roots here is none. Now we will discuss here about the different cases of discriminant to understand the nature of the roots of a quadratic equation. So we know that x sub 1 and x sub 2 are the roots of the general form of the quadratic equation, ax squared plus bx plus c equals 0, where a should not be equal to 0. Then we get x sub 1 equals negative b plus square root of b squared minus 4ac over 2a, and x sub 2 equals negative b minus square root of b squared minus 4ac over 2a. So here a, b, and c are real and rational. Then the nature of the roots x sub 1 and x sub 2 of the equation, ax squared plus bx plus c equals 0, depends on the quantity of the expression b squared minus 4ac under the radical sign. Thus, the expression b squared minus 4ac is called the discriminant of the quadratic equation, ax squared plus bx plus c equals 0. So generally, we denote discriminant of the quadratic equation by a triangle, or this is delta, or capital D. Therefore, discriminant is equal to b squared minus 4ac. Then, depending on the discriminant, we shall discuss the following cases about the nature of roots x sub 1 and x sub 2 of the quadratic equation ax squared plus bx plus c equals 0. When a, b, and c are real numbers and a is not equal to 0. Case 1, b squared minus 4ac equals 0. So when a, b, and c are real numbers, a is not equal to 0, and discriminant is 0, b squared minus 4ac equals 0, then the roots x sub 1 and x sub 2 of the quadratic equation ax squared plus bx plus c equals 0 are real and equal. Example, find the discriminant value of x squared minus 12x plus 36 equals 0 and determine the number of real roots. So for the solution, we are going to identify the values of a, b, and c. So the given equation x squared minus 12x plus 36 equals 0. The equation is in the form ax squared plus bx plus c equals 0, where a equals 1, b equals negative 12, and c equals 36. The second step is we're going to substitute the values of a, b, and c to the discriminant b squared minus 4ac. So you have there in your module, discriminant equals b squared minus 4ac equals the value of b, negative 12 squared, minus 4 times the value of a, which is 1, times 36, the value of c. Negative 12 squared is 144, then negative 4 times 1 times 36 is negative 144, so 144 minus 144 equals 0. The third step is we're going to describe the nature of the roots. Now, since the discriminant value of the equation is 0, then the equation x squared minus 12x plus 36 equals 0 has a double root, and the roots are real and are equal. So this can be checked by determining the roots of x squared minus 12x plus 36 equals 0 using any of the methods of solving quadratic equations. If factoring is used, the roots can be obtained are the following. X squared minus 12x plus 36 equals 0. So the factors of 36 in which the sum is negative 12 or negative 6 and negative 6. So negative 6 times negative 6 is 36. And if we're going to add a 2, the answer is negative 12. Then using zero product property, x minus 6 equals 0 or x minus 6 equals 0. And we can have our value of x equals 6. So there are two roots but same value. So this is called as double root. So the roots of the quadratic equation, x squared minus 12x plus 36 equals 0, are real numbers and are equal. Then you have there example number 2. You can just figure it on your own. So the same with number or example number 1. In case number 2, b squared minus 4ac is greater than 0 and a perfect square. So this is positive and a perfect square. Example is 1, 4, 9, 16, and so on. So when a, b, and c are real numbers, a is not equal to 0, and discriminant is positive and perfect square, then the roots x sub 1 and x sub 2 of the quadratic equation ax squared plus bx plus c equals 0 are real, rational, and unequal. Example 3 here, find the discriminant value for the equation x squared plus 5x plus 6 equals 0 and determine the number of real roots. So step 1, identify the values of a, b, and c. So for this one, the values of a, b, and c are a equals 1, b equals 5, and c equals 6. Next step, we're going to substitute the values of a, b, and c to b squared minus 4ac. So b here is 5, so we're going to have 5 squared minus 4 times a equals 1 times 1, c equals 6, so times 6. 5 squared is 25, then minus 4 times 1 times 6 is 24. So we have there 25 minus 24, it is equal to 1. Step 3, describe the nature of the roots. Since the discriminant value of the equation is greater than 0, positive, and a perfect square, then there are two real roots of the equation, x squared plus 5x plus 6 equals 0, and the roots are rational numbers but not equal. This can be checked by determining the roots x squared plus 5x plus 6 equals 0 using any of the methods of solving quadratic equations. Now, if factoring is used, the roots can be obtained are the following. X squared plus 5x plus 6 equals 0. So the factors are x plus 3 times the quantity of x plus 2. So x here is equal to negative 3 and x is equal to negative 2. So the roots of the quadratic equation, x squared plus 5x plus 6 equals 0 are negative 3 and negative 2. So there are two real roots but they are unequal. So just figure out how example 4 is done. Then let's have case number 3, b squared minus 4ac is greater than 0 and not perfect square. When a, b, and c are real numbers, a is not equal to 0 and discriminant is positive. B squared minus 4ac is greater than 0 but not a perfect square. Then the roots of the quadratic equation ax squared plus bx plus c equals 0 are real, irrational, and unequal. Here the roots x sub 1 and x sub 2 form a pair of irrational conjugates. Example 5. Describe the nature of the roots of the quadratic equation 2x squared minus 8x plus 3 equals 0. So the coefficients of the equation 2x squared minus 8x plus 3 equals 0 are rational. Then the discriminant of the given equation is b squared minus 4ac. b is negative 8. So negative 8 squared minus 4 times a, which is 2. And c equals 3. So negative 8 squared is 64. Then 4 times 2 times 3 is 24. So 64 minus 24. This is equal to 40. So clearly the discriminant of the given quadratic equation is positive but not a perfect square. Therefore, the roots of the given quadratic equation are irrational and unequal. To check, solve for the roots of 2x squared minus 8x plus 3 equals 0 using the quadratic equation or quadratic formula. So x here is equal to negative b plus minus square root of b squared minus 4ac over 2a. Substitute the value of b, so negative of negative 8 plus minus square root of b squared, so negative 8 squared minus 4 times a 2 times c 3 over 2 times the value of a 2, 2 times 2. Negative of negative 8 is 8 plus or minus square root of 64 from negative 8 squared. Then minus 4 times 2 times 3, which is 24 over 2 times 2, 4. Then x here is equal to 8 plus or minus square root of 40 over 4. Then square root of 40, this is equal to 4 square root of 4 times 10. So square root of 4 is 2. That is why it became 8 plus or minus 2 times the square root of 10 over 4. Then x of 1 here will be 8 divided by 4 is 2 plus 2 divided by 4 is 1 half. So it became square root of 10 over 2. And x of 2 here is equal to 2 minus square root of 10 over 2. So the two roots here are irrational and not equal. In case number 4 is b squared minus 4ac is less than 0. So when a, b, and c are real numbers, a is not equal to 0 and discriminant is negative, then the roots x of 1 and x of 2 of the quadratic equation, ax squared plus bx plus c equals 0, are unequal and imaginary. Here, the roots x of 1 and x of 2 are a pair of the complex conjugates. So, imaginary meaning they are not real numbers. Example 6, find the discriminant value of 2x squared plus x plus 3 equals 0 and determine the number of real roots. So, identify the values of a, b, and c. A equals 2, b equals 1, and c equals 3. Then substitute the values of a, b, and c. We can have b squared minus 4ac. b is 1, so 1 squared minus 4 times a is 2 times 2. c equals 3, so times 3. 1 squared is 1. Then 4 times 2 times 3 is 24, so that is why it became minus 24. So 1 minus 24 is negative 23. Now, since the value of the discriminant in the equation is less than 0, then the equation 2x squared plus x plus 3 equals 0 has no real roots or imaginary. Also, the graph of this equation does not touch the x-axis. So to check, solve for the roots of 2x squared plus x plus 3 equals 0 using the quadratic formula. You can have the given here. Negative 1 plus or minus square root of 1 squared minus 4 times 2 times 3 over 2 times 2. So x here is equal to negative 1 plus and minus square root of 1 minus 24, which is square root of negative 23. So you have your answer as x sub 1 equals negative 1 plus square root of negative 23 over 4. The other one is x sub 2 equals negative 1 minus square root of negative 23 over 4. So hence the given or the roots are imaginary or not real. So you have the example number 7, just figure it out. Then let's have activity 4, find my nature. So directions describe the nature of the roots of the quadratic equation using its discriminant. So you have an example here, 3x squared minus 2x minus 5 equals 0. Discriminant is 64. So if you're going to substitute or use b squared minus 4ac, you can get 64. Nature of roots is rational and unequal. Again, you're going to use here b squared minus 4ac AC. So you need to find the values of A, B, and C and substitute it in the discriminant b squared minus 4ac. Then activity 5, let's do some framing. Directions: study the situation below, then answer the questions that follow. So a rectangular frame has an area of 14 square inches and a perimeter of 18 inches. Find the dimensions of the rectangular frame. So the figure below shows how to set up the problem. So you have there L times W equals 14. This is for the area. And for the perimeter, it's 2L plus 2W equals 18. Then activity 5, is it possible? So you'll just answer the following questions. So there are 3 questions and just write your answer on your paper. Then activity 6, using discriminant in real life. Directions: answer the following problem. So you have there the problem, and what you're going to do is you will just answer what is being asked. Then let's have lesson 2, the sum and product of roots of quadratic equations. So you have the activity 1, relate me to my roots. Direction: consider and carefully analyze the table below. So we'll just analyze here. So you have there quadratic equation number 1, x squared plus 7x plus 12 equals 0. So if we're going to find the roots are negative 3 and negative 4. Sum of the roots, if we're going to add the 2, negative 3 plus negative 4 is negative 7. Product is negative 3 times negative 4 is 12. A equals 1, B equals 7, and C equals 12. So you have their process questions, so answer the 3 questions. Then activity 2 here, sum and product puzzles. Direction: observe the following puzzle and complete the given problem using your skills on the basic mathematical operations. Write your answer in the box. Example: find 2 factors whose product is 10 and sum is 7. So for this example, the product is 10 and the sum is 7. So if we're going to add 2 plus 5, sum is 7. If we're going to multiply the 2, 2 times 5, this product is 10. So you're going to do the same with the 9 numbers in the activity 2. Then activity 3, find my roots. Direction: find the roots of the following quadratic equation using any of the method: extracting square roots, factoring, completing the squares, or using the quadratic formula. So this is a sort of review on how to solve quadratic equations. So you can use any of the method. Then activity 4, are we related? So given the following quadratic equation, complete the table below, then answer the following questions. You may work in groups of 4. The first one is done for you. So example for number 1, x squared plus 4x minus 12 equals 0. This is the quadratic equation. A equals 1. B is equal to 4. This is not 8. 4, not 8. And C equals negative 12. So if we're going to find the roots using any of the methods, we can have the roots as 6 and negative 2. If we're going to use factoring, 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So these are the roots, 6 and negative 2. If we're going to add the roots, 6 plus negative 2, the sum is 4. And if we're going to multiply, the answer is negative 12. So in here, you're going to answer the process questions. And you're going to supply the missing data on quadratic equations number 2 and 3. So you're going to find the coefficients, roots, sum of roots, and product of roots. Then activity 5, stretch me out. Study the given problem and answer the questions that follow. So a picture has a width that is 4/3 its height. It has an area of 192 square inches. What will be the dimension of the picture? What is the perimeter of the picture? So for the hint, you're going to use here area equals length times width, and perimeter equals 2L, twice the length plus twice the width. Then we will now discuss now the sum and product of the roots of the quadratic equation ax squared plus bx plus c equals 0 can be determined using the coefficients a, b, and c. So we have seen that the b squared minus 4ac is the radicand of the quadratic formula called the discriminant, can tell us the type of roots of quadratic equation. Then the quadratic formula can also give us information about the relationship between the roots and the coefficient of the second term and the constant of the equation itself. Consider the following. Given a quadratic equation ax squared plus bx plus c equals 0, by the quadratic formulas, the two roots can be represented as r sub 1 equals negative b plus square root of b squared minus 4ac over 2a, and r sub 2 equals negative b minus square root of b squared minus 4ac over 2a. So if we're going to have the sum of the roots, we're going to have r sub 1 plus r sub 2 equals negative b plus square root of b squared minus 4ac over 2a plus negative b minus square root of b squared minus 4ac over 2a. So adding the two, we're going to have negative b plus square root of b squared minus 4ac minus b minus square root of b squared minus 4ac over 2a. Negative b plus negative b is negative 2b, then b squared minus 4ac, square root of b squared minus 4ac minus square root of b squared minus 4ac equals 0. So we are going to have in the numerator negative 2b over 2a. Then negative 2b over 2a, the result here will be negative b over a. So we're going to have the sum r sub 1 plus r sub 2 equals negative b over a. And if we're going to have the product of the roots, r sub 1 times r sub 2, this is equal to negative b plus square root of b squared minus 4ac over 2a times negative b minus square root of b squared minus 4ac over 2a. Then negative b times negative b is b squared. This should be equal to b squared. Then negative b times negative square root of b squared minus 4ac, this should be plus b, plus times square root of b squared minus 4ac. Then square root of b squared minus 4ac times negative b is negative b times square root of, this should be times square root of b squared minus 4ac. Then square root of b squared minus 4ac times negative square root of b squared minus 4ac, you have there negative b squared minus 4ac. Then over 2a times 2a is 4a squared. So you have there your answer as b squared, then b times b squared minus 4ac minus b times b squared minus 4ac is 0. Then you have there negative of b squared is negative b squared. Then negative of negative 4ac is positive 4ac. This one. Then over 4a squared. Then simplifying this one, b squared minus b squared is 0. So you have 4ac over 4a squared. Then simplifying this one, cancel 4a and a here. So remaining here is a. So the answer is c over a. So r sub 1, it should be times r sub 2 equals c over a. So the sum of the roots of a quadratic equation is equal to the inverse of the coefficient of the second term divided by the leading coefficient. So r sub 1 plus r sub 2 equals negative b over a. Then the product of the roots, r sub 1 times r sub 2 is equal to the constant term c over the leading coefficient a. So example 1, find the sum and product of the roots of quadratic equation x squared minus 5x plus 6 equals 0. So for the solution, a equals 1, b equals negative 5, and c equals 6. So sum of the roots here is negative b over a. So we have negative of the value of b, which is negative 5. So negative of negative 5 over 1. Then this is equal to 5. Then the product of the roots is c over a. C is equal to 6. And b equals a equals 1. So the answer here is 6. Therefore, the sum and product of roots of x squared minus 5x plus 6 equals 0 are 5 and 6 respectively. Then you have their example number 2, so just figure it out on your own. So activity 6, find my roots, direction using the values of a, b, and c, each of the following quadratic equation. Solve for the sum and product of roots. Check your answer by using the roots of the quadratic equation, then answer the question below. So x squared plus 3x minus 10 equals 0. So sum of the roots, we are going to use negative b over a. So b is 3, so we're going to have negative 3 over 1, which is equal to negative 3. Then for the product of the roots, we're going to have c over a. C here is negative 10 over 1. So negative 10 divided by 1 is negative 10. So what we're going to do is we're going to have the roots. So for the roots, we're going to find two numbers. So sum is negative 3 and whose product is negative 10. And those numbers are negative 5 and 2. So negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So do the same with the given 4 quadratic equations. Then for activity 7, just answer the questions in your paper. Activity 8, find my match. So direction match column A, the roots, with column B, the quadratic equations. So you're going to match here the given roots to the quadratic equation on column B. So example here, number 1, 5 and negative 14. So if we're going to have their sum, 5 plus negative 14 is negative 9. And if we're going to use the sum and products of the roots, this is negative, the sum is negative 9, so we're going to have its opposite, so negative 9. So opposite of negative 9 is 9. So the value of b here is 9. And if we're going to have their product, 5 times negative 14, this is negative 70. So our possible answer here should be letter C. X squared plus 9x minus 70 equals 0. So again, you're going to use here sum r sub 1 plus r sub 2 equals negative b over a, and the product is c over a. So in here you can find the values of a, b, and c to have the quadratic equation. Then activity 9, so just follow the directions on the activity. Then for the last part, you're going to have or answer the assessment, the post test. This is numbered 1 to 20. So that's it for this video. Thank you and good day.